Here is another brilliant question for our IBHL students based on exponential and logarithmic functions. Enjoy the journey with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here we have a very beautiful question based on exponential functions. It is from IBHL test paper. In this series, you will find many questions from past test papers, and if you go through the playlist, you will learn a lot. The question here is we are given the function f of x as equal to e to the power of x plus e to the power minus x over e to the power of x minus e to the power minus x. In part A, we need to find inverse of the function, and in part B, we need to show that function of inverse of a function is equal to x. Well, that statement is true for every one-to-one function, right? So function of inverse of a function is always x, but we need to show it. You can always pause the video, answer the question, and then look into my suggestions. Well, let me also thank all the viewers and subscribers for watching my videos, posting excellent comments, and sharing their views. Well, this is your channel. You post questions, we provide you with solutions that matter and are of quality. We have been serving you absolutely free for the last 15 years, as you know, with 17,000 free videos. We are uploading every day, almost every day, one video, if not more. And these are being watched over 80 countries. Our channel is indeed international. Every video prepared here is good for American students, Canadian students, Indian students, or students anywhere in the world. Now, to support our services, some of you are contributing. We are very thankful to them, but we need more contribution. Every dollar counts. So, whatever you can, please do contribute. Students in Canada can contribute using the email transfer, and for others, if you want to regularly support, in that case, please send an email to us and then we can work out the method of payments. Enjoy the free videos for all times to come. Now let's get back to the question at hand, which is solving this exponential function, finding its inverse. Now, as such, it is a difficult question. So let me write down this in terms of y equals to what? So y equals to e to the power of x plus e to the power of minus x over e to the power of x minus e to the power of minus x. Now we can actually rewrite this multiplying numerator and denominator by e to the power of minus x. Then we will get what? Well, we get e to the power of, or you can say we can take e to the power of minus x common, right? We can do that also. In that case, we get e to the power of 2x plus 1. And here also we can take e to the power of minus x common, getting e to the power of 2x minus 1, right? Now e to the power of minus x will cancel, and therefore we can rewrite this as y equals to e to the power of 2x plus 1 over e to the power of 2x minus 1. You see that? So we come to a simpler equation. I know the power is double now, but that can help you to find the inverse of the function. Now to find inverse, what we are going to do? We'll swap x and y, right? To find inverse. So let's see how do we find inverse now, right? So once you do that, what do you get? Instead of y, you get here x equals to and e to the power of 2y plus 1 over e to the power of 2y minus 1, correct? Now see what happens when I add 1 on each side, or if I subtract 1, then what happens, right? So let's see that. So if I do x minus 1, for example, then I get here e to the power of 2y plus 1 over e to the power of 2y, e to the power of 2y. There's very less space here, so kind of constrained. So we'll just squeeze things in. So we have subtracted 1 from both the sides. So we get here x minus 1 equals to e to the power of 2y plus 1 minus e to the power of 2y minus 1 over e to the power of 2y minus 1. Clear? So in the numerator, e to the power of 2y minus e to the power of 2y is 0. 1 minus minus 1 is 2. So we get 2 over e to the power of 2y minus 1. Is that clear to you? See, we have simplified it a lot. And now we can cross multiply. So once I do that, I'm changing the color also. E to the power of 2y minus 1 equals to 2 over x minus 1. Clear? So what is e to the power of 2y? E to the power of 2y will be equals to 2 over x minus 1 plus 1, correct? Which is 2 plus x minus 1 over x minus 1, right? Which is, we get x plus 1, right? Over x minus 1. Do you see that? So we get e to the power of 2y as equal to x plus 1 over x minus 1, correct? So let's take it to the next page. So we have e to the power of 2y. Let me rewrite here. Equals to x plus 1 over x minus 1, correct? So that is what we now get. We are finding the inverse. So now we can isolate y, right? Taking ln both sides, correct? If you take ln both sides, so what do we get? We get ln e to the power of 2y equals to ln x plus 1 over x minus 1. Correct? So ln and e are inverse of one another, and therefore what we get is 2y equals to ln x plus 1 over x minus 1, or y equals to half of ln x plus 1 over x minus 1. Is that clear to you? Half. You could write it power of 2 also you could write, right? So that is what we have written. So now we have found the inverse of the function, right? So let me write down f inverse now. So as you can see very clearly, so we got the f inverse of this function as equals to half ln x plus 1 over x minus 1. Clear? Some of you may write like this, ln square root of, right, x plus 1 over x minus 1. So that is also correct, right? So that becomes the inverse of this function. Is this absolutely clear to you? Perfect. Now, you see, if you really want to learn from me, you can send an email on globalmathinstitute@gmail.com. Also, feel free to support us. That is very important at the moment. Let's continue with our function. So we have found the inverse of this particular function. And now we are going to do part B, which is f of f inverse x, right? Now, to find f of f inverse x, we could use the function as such, or we could use the simplified form, correct? So I prefer to use the simplified form f of x as equal to e to the power of, we said 2x, right, plus 1 over e to the power of 2x minus 1. Is that clear to you? So that simplified form is indeed better to use at this particular stage, right? And now we'll find what is f of f inverse x in the next page, right? So clearly, if I use this inverse yes, power is half, right? So when I do times 2 of the same thing, then this component goes, right? So what do we get? Let me rewrite on the next page. So we are now going to calculate f of f inverse x using what we just derived here, right? These two. So what we have is f of x is e to the power of 2x plus 1 over e to the power of 2x minus 1, and f inverse x as ln square root of, or you can write x plus 1 over x minus 1 square root, right? That is what we have. And now we are going to find what is f of f inverse x, correct? So let's rewrite. So f of inverse is already known to us, f of ln square root of x plus 1 over x minus 1. Clear? Substituting this value here, we get e to the power of 2, and then we have all this ln square root of x plus 1 over x minus 1 plus 1 over e to the power of 2 ln square root of x plus 1 over x minus 1 minus 1. Is that clear to you? Correct? So now e to the power of 2 ln this is basically equal to, we can rewrite this as x plus 1 over x minus 1 plus 1, correct, over x plus 1 over x minus 1 minus 1. Is that clear to you? Right? And now this, you can take common denominator x minus 1, and so what do you get? So let me write down here f of f inverse x equals to. So I'm going to simplify it here. We get x plus 1 plus x minus 1, right? Over x minus 1 over x plus 1 minus x minus 1 over x minus 1. Clear? So x minus 1, x minus 1 cancel. And x plus 1 plus x means 2x, right? Over, we have x and x cancel, 1, 1 is 2, and which is equal to x. Do you see that? So we have shown that f of f inverse x is indeed x, right? So a lot of algebra goes into this to get the solution. But I hope you understand the whole process. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. And in case you want to learn directly from me, send an email to globalmathinstitute@gmail.com. Also, support us. Thank you and all the best.